So today we are going to continue with the OSI reference model. It is open system interconnection model. Yesterday we discussed the brief about it, and we we have also understood the basic structure of this OSI model. In computer networks, we have two models, OSI model and TCP/IP models. So the OSI model is, you can say that a very detailed model in which for every task we have a different layer. But in TCP/IP layer, there are generally four layers, and some layers are combined in it. So what layers are combined in TCP/IP, that we will discuss when it will come. So and this OSI model is the theoretical part, theoretical model, and the actual implementation is on the basis of TCP/IP model. But still, we have to understand that what layer will perform which type of act, so that our data will be safely and securely transmitted from source to the destination. So yesterday we discussed that we have seven layers, and starting from bottom to top, we have physical two. We'll move from physical layer to application layer by visiting the data link layer, network layer, transport layer, presentation layer, session layer, presentation layer, and application layer. So the first layer, that is physical layer. So it is the layer that will be, you can say that, directly connected to the transmission medium. Means that link will be directly connected with transmission medium, and using that link, the data will be transmitted to the medium, as well as the data will be received from the transmission medium, whether it is wireless or it will be wired network or wired medium. Okay, so this physical layer is responsible for transmitting the individual bits from one to the next. Like we have these kind of bits in it, 110, and they will be transmitted like this: 0, 0, then followed by 1, then again 1, then 0, and then 1. Okay. So it also responsible for physical characteristics of interface and medium. So that means it will handle the interface as well as the media on which the data is being transferred. So in this, we have the representation of bits. The stream of bits like zeros and one will be there. No other form of data will be there. Even if we have the data in image form or text form, or in any kind of like word files, uh, MP3 files, video files, all this data will be stored like this in it. Okay, so storage means storage means not the storage, but the transmission from one system to the another system. Then the data transmission will depends upon the data rate at which the data is being transferred. So suppose if the data rate of the medium is 10 Mbps, okay, then at the maximum speed, the data will be transferred at 10 MB per second or lesser than that. Okay, this is the maximum speed that will be uh, covered by this transmission media. So then synchronize of bits is there, that the data should be synchronized And line configuration is there. Line should be configured before transmitting of data to the uh, receiver side. Topology, how the data will be transferred, and then transmission mode. So in the advancement of the syllabus, we will see what modes will be used. It is tunnel mode. One is the tunnel mode, and some other modes are there in which the data is being transferred from source to the destination. So that is also the task of this physical layer. So this is the structure of this physical layer. The data will come from the data link layer, and this line shows the header of the data. It will contain what is the source address, what is the destination address, what is the error detection code in it, what data is related to. So these kind of data will be transferred from physical layer to the physical layer of the destination address via a transmission medium. Okay, and at this point the source address will be checked, the destination address will be checked, the error detection code, it will be used to detect whether there are any errors in this data, and then the data will be shifted to data link layer. So the circuit or the diagram for this will be, we have 1, then 0, 0, 0, then again 1, then 0, 0, 0, then 1, 1, and 1. So this will be the circuit for it. Clear? Okay, so next is the data link layer. It is responsible of moving frames from one hop to the next, one node to the next node. Basically, that data link layer deals with the frames at the sender side and as well as the receiver side. So now let's understand what is a frame or framing. It will divide the stream of bits received from the network layer manageable into manageable data units. Like suppose we have a, this is the data that will come from the network layer. So what it will do is it will divide the this data into number of frames, and now give it to sequence number like 1, 2, 3, and 4, and similarly at the other side So 1 and 2, 3, 4, 1, 2, 3, 4 sequence numbers will be allotted, and the data will be sent from like these sequence numbers to the physical layer, and the physical layer will receive only the frames. So physical address will be implemented like MAC address. Flow control is there. If the speed of the sender is fast, whereas the receiving speed is slow, so that will be controlled by the data link layer. Error control is also there. It will add tailor to the end of the frame to detect the error controls. Access control is there. Authentication type of implementation is there, and hope to hope delivery responsible for delivery of the correct packets from source to the destination. Here, so the physical layer framing in which the framing is being implemented, framing, then physical addressing, addressing of the packets, then flow control, error control, as well as access control. So the data will be transmitted like this from intermediate node to the device B, and these are the frames that will be transmitted from network layer to the data link layer, and data link layer will send the frames to the physical layer. It will send the data frame wise, that for a particular packet, one frame, then second, then third, and similarly these frames will be collected at the receiver side. Okay, so these 5 activities will be there, and like this, the data will be transmitted from sender to the receiver. So clear with this data link layer? So this is the node-to-node delivery by data link layer. So and the system, it is communicated with this intermediate system, and intermediate systems are then again linked with other intermediate systems till we reach at the destination. So when A delivers the data at the B, up to this up to network layer, the data will be transmitted not at the not up to the application layer. So here bits are arranged in frames, and arranged the frames will be sent to this data link layer. Okay, so first of all, the whole data will be transmitted to this B, like this intermediate node, and it will collect the data, and then as per the header it will check the destination address and send the data to the other system, like at B, at this point, at B point, it will check the destination address is D, this system. Okay, so rather than sending the data to this route, it will send the data to system intermediate system C, and if the destination address is F, the data will be transmitted to this link. So now destination address is F. So at this point, the data from B will be transmitted to E. Same steps will be implemented over here in E, and then the data will be transmitted at the end to the F, and at this point it will move to the application layer, and the user will access the data. Clear? So next, network layer. So this layer is meant for the delivery of individual packets from the original source to the final destination. So logical address will be implemented if the packet passes the network boundary. We need another addressing system to help source to the destination connection. So that is why the logical addressing will be used. Like this network, if this system wants to communicate with this, so logical addressing will not be implemented because we are in the same network. But if suppose this is the another network, and this system, these are the systems, and this system wants to communicate with this system, so we need the logical addressing because here the network is changing over here. So route or switch the packets to the final destination, then routing is there to send the packet to the actual destination. So basically this layer is responsible for source to destination delivery. So this is the network layer. The data comes from the network transport layer in segments. You can say that packets. See, the number of segmentations are there. First of all, the data is transmitted in segments from the transport layer, and then at the same segment will be partitioned into frames. Okay, so network 1 layer will connect to the network 2 of the receiver, IP2 of the receiver. So again, this is the same method that we have already discussed in the previous slide, that this is the source to destination delivery uh, from system A to F. So this is it with today's lecture. If you have any query, you can ask me in the chat box. Till the time I am going to mark your attendance, so nobody will leave